Next, one more important problem. Using Millman's theorem, find current through 5 plus 5J. So this is the impedance, load impedance is a AC problem. This is a AC problem. This is ZL. ZL is 5 plus 5J. This is ZL. So it is a AC problem. But AC, they are given resistance only. Here they are given resistance only. Okay, R1, E2, R2, E3, R3. But here Millman's theorem states that if many parallel voltages are connected in parallel, that can be replaced by single parallel voltage source. But here this is a voltage source, this is a voltage source. But in the given problem, this is current source. 5 amps with 4 amps parallel is a current source. So we need to convert this current source into voltage source. So V is equal to IR. It is how to convert current source into voltage source. So value of I is 5, R value is 4. So it is 5 into 4, it is equal to, it becomes 20 volts. So if I convert and arrow mark side plus, arrow mark side plus, arrow mark side is plus. Okay, this side negative. And same value of this 4, no, same value of 4 you have to connect it in series. If I convert current source into voltage source, V is equal to I into R, just multiply I value with R value. Okay, these two are in parallel now. Convert I with R and same value of R you have to connect in series. For always voltage source you have to connect series resistance. The current source you have to connect parallel resistance. So this is converted into voltage source. This source is converted into voltage source. Now it is in the form of three parallel voltage sources are connected in parallel. So we can apply Millman's theorem and instead of these three, we can obtain single voltage value and single resistance. So this is the Millman's equivalent voltage. So that is the value of V, what is the value of R, we have to calculate. So the value of E, okay, this you can consider as E. So this one you can ignore. What is the value of E? You can write as E is equal to, okay, this E1 by R1, E2 by R2, E3 by R3, whole thing divided by 1 over R1 plus 1 over R2 plus 1 over R3. So this here E. So it is 4 by 2 plus 8. This current, if I convert this one to current, current will go upwards. If I convert this one to this, current will go upwards. If I convert this one, current will go upwards. Already, if I convert this voltage source to current source, you can see here, we reversed it, converted current source into voltage source. So here also you can convert this one to current source. This is already in current source now. Again, if I transform this one to voltage current source, you will get this. Again, similarly, if you convert this one to current source, 8 by 3 is the current and it is going upwards and same 3 ohm you have to connect it in parallel. This 4 by 2 is the current going upwards and same 2 you have to connect it in parallel. So it is a net voltage. Now if you calculate, you will get 8.923 and R value. Okay, value of R, instead of R dash or R, I am writing R only. So it is 1 by R1 plus 1 by, it is 1 by R1 plus 1 by R2, 1 by R3. This is 1 only. So now we'll calculate using calculator. I'll take this one is 4 into 2 inverse plus 8 into 3 inverse plus 20 into 4 inverse divided by 2 inverse plus 3 inverse plus 4 inverse. It is 8.923. 8.923 we are getting the answer and it is unit is volts. Next we have to find equivalent resistance, Millman's equivalent resistance. It is equal to reciprocal of 1 by R1 plus 1 by R2 plus 1 by R3. So I'll calculate once again. Okay, 1 divided by, so in the numerator 1 divided by 2 inverse, 1 by 2 means 2 inverse, 3 inverse plus 4 inverse is 12 by 3. It is 923. Okay, 923 ohms. So after that, we have to write equivalent resistance. Okay, this is a minimal equivalent circuit with resistance value is equal to R value is equal to 0.923 ohms. E value is equal to 8.923 volts, and we have to connect same value of ZL. ZL is what it is. It is now I am writing. This is ZL 5 plus 5J. So now current is given by IL. Current is given by E divided by Z plus ZL. E value is 8.923. If it is pure DC network, we'll get only R. R in general, we can write Z plus ZL only. So here 0.923 plus 0.923 plus 0J. Okay, because resistance is there, reactance is not there, plus 0J plus ZL. ZL both are there, 5 plus 5J. This is resistance, this is load impedance. So if I calculate this, I'm going to get this much. Let me check now. For doing this, for a complex network, please note down, for this type of problem, you should go to complex mode. Complex mode is 2. Select 2 mode. Now click on this 8.923 divided by 0.923 plus 5 plus 5. I instead of J, you have to click ENG button I. You see here, you should go to mode, select complex mode, then click this numerator, you type this, denominator, wherever J is there, no, you type ENG, but above that your I is there. So better use this type of calculator only for exam. You are going to get, you will see only this much, or you can click ST button. It's, it is 0.8796 minus 0.74 I, no, instead of I, don't write I, J you write, minus J 0.74. You have to keep answer both in rectangular and polar. This is rectangular. I want to put the answer in because in the scheme of evaluation they may give this answer. Okay, sometimes they may give this only. We are getting this answer, but if in the scheme, if they give this answer, the evaluator will have some confusion whether it is correct or wrong. So better you keep answer both in rectangular as well as polar coordinate. Now convert into polar form. So this value is 1.15 is root of 0.87 square plus 0.74 square is this much, and this is tan inverse of this by this. Okay, so now here shift, you have to click shift plus complex shift. There is a CMPLX here written here in the 2 button, above 2 button there is a CMPLX complex. So we selected shift, you can see here S is there, shift complex, 4 options there, argument of that, conjugate of this one. Conjugate means it will give opposite of this. Then r angle theta means it's polar coordinates. A plus bi means rectangular coordinate. I want the answer. Already we already obtained the answer in rectangular. This in this format. I want this also. To get this, you have to select third option 3. So it is 1.151 angle 40.6169, or you can click ST button. 1.151 angle 40.6. This is a very, very important problem because they are given current source, so you need to convert it into voltage source. After that, you can apply Millman's theorem. Millman's theorem converts many parallel voltage sources into single voltage source in series with resistance. After that, what is the value of E is this formula you have to write. Formula 1 marks will be there. For this also 1 marks will be there. Find the value of effective Millman's equivalent voltage, Millman's equivalent resistance, and connect the same ZL here. This portion, left side portion is Millman's equivalent circuit. Now connect same ZL. Now it is a very simple circuit. Voltage in series with the two impedance. Okay. The current is given by voltage value divided by sum of these. Okay. Can easily calculate. Thank you.